Hi everyone. This is just to give you a little overview of the concepts and principles involved in understanding optics, which really boils down to image formation and kind of how we see things and how we form images of things that we look at. So I want to start just very generally, just to think about, what actually happens when light is traveling from some object here. And I'm just going to pick something simple. So here's going to be like a tree, right? So there's a tree that you might be looking at. And one of the things that's really confusing about the diagrams that you tend to see for optics stuff is that it gets quickly kind of glossed over that you're just looking at a single point and the light coming from that point, and then to make the full image of the object like this tree, you have to piece all those points together, so like, for example, if I focus on that tip of that branch right there, I could think about there's light coming out in all directions from that branch, right? And then when my eye's over here somewhere looking at it, I'm receiving that light. But there's also light coming from this point and going off in all directions. And there's also light from, any other point going off in all directions. And if I want to, the easiest way to kind of focus it is to think about one of those particular points and understand what's going on and then assemble that all together. So I'm going to do that first. Okay. So let's talk about, let me make a different color here. So let's talk about, let's say we've got a little point here, and there's two different kind of categories of ways that you could easily think about the light traveling out from there. One is, you can think of it, I like to picture it as almost like ripples on a pond. So if you imagine that, I'm looking down on the surface of a pond here, and a drop of water landed right there, and then you could imagine, right, there's going to be ripples. They're going to go out. Something like that. There's a video, short little 10-second video in the lecture slides for today that show you a visual of, actually ripples from a pond going out like that. And so you could think of what's happening here as the spacing between these two ripples is the wavelength, and there's something jostling up and down. Again, if you're looking into the page here, there's something jostling up and down here, and it's sending out ripples like this. Okay, and then the other way I can picture it is, as indicated kind of by what I'm doing here. If you focus on one part of a ripple, there's a motion of energy that, we call it the wave, that is moving outward in the direction that's basically perpendicular to the surface of these ripples, right? So let me just put some labels here. So this diagram that I just drew here, this is the wave picture. The other picture that I could indicate, I'll just label it over here, is going to be called the ray picture. And that is the part that talks about the direction that the light is going, right? So this, I could think of a ray of light going out in this direction that's perpendicular to all of those wave fronts, the ripples, right? Or there's one going this way and one going this way, and so on, right? So I've got these rays going out, and I can think of using those rays as a way to trace the light. Right. So I could think of each of those rays as tracing which direction the light's going. Let me go back to my pen. Just, there's a ray. Okay. And so when we're doing optics, when we're doing what's called geometrical optics, if I can spell it, optics, uses the rays because using the rays is the easiest way to think of tracing it, right? It's hard to work with these wave fronts, these ripples. It's much easier to think about a ray of light going in a particular direction. It's sort of more direct for understanding what's happening most of the time. Okay, so that's the picture. And you can think about, um, okay, so yeah, so that's the general picture. And then if you want to think about something being like in focus, you can think about it like there's from this one point, one place on the object, light was going out in all different directions. And in general, that light never comes back together. And if you were looking to see like where did all that light come from, you can see how you can trace each of these rays back to the point where they come together, right? That's the place where the ripple formed, if you want to think of it that way. But from your eye's point of view, let's draw an eye here. So let's imagine, what color have I not used yet? Let's imagine that here's a side view of somebody's eye, right? There's like a side view of your eyeball there, maybe some eyelashes, right? And you're looking at this light coming towards you. You can, what you are doing when you say, well, the light came from this point over here, is you're basically extrapolating back these rays and seeing where they originated from. Let me draw a few more rays in here, right? So there's one making it to your eye, very crooked looking one, they're supposed to be straight, making it to your eye and so on, right? And from your eye's point of view, if you trace those rays back, it looks like they came from that single point. Okay, so with that kind of background in mind, now we can start to think about, well, what happens if I use a lens to make an image of something? So the idea here is that I can now, instead of now I'm going to shift to a new picture here. So I'm just going to make a point, and I'm going to call this, that's going to be the object. Okay. And I'm going to put a lens here somewhere. And in particular, this is going to be what's called a converging lens, because converging meaning it brings the light together. You'll see what I mean in a second here. So if I have rays of what this lens does is it takes light that was coming out in a variety of directions, and it's using refraction, which you'll see discussion of in the lecture notes, to bend the light as it goes through this could be glass or plastic or whatever in the lens. It's going to bend it so that these rays are going to come, instead of continuing to go forever outward, when they pass through here, they get bent in such a way, depending on the angle that they come in at. It's not the greatest drawing, but I think you can see what I mean. They get bent in such a way that they all come back together at another point here, and that point is what we call the image. And again, this is where I was saying at the beginning, it's confusing because now you have to think of that point is just one point on the object, right? And if I really wanted to form the full image here, I'd have to do this same tracing for each of the points on the object, right? Okay. But the idea for you to see here is like in the ray picture, if I have these rays going like this, they're coming back together at this point again. And so then if I look at them, right, and maybe I could put my eye, out here now. Once they've come back together, they're gonna, unless I put a screen here or something, right? I could put a screen right here, and like a movie screen, and that would be forming an image that would be projected onto that screen. I could also just let the light continue on past. But then notice the cool thing here is that now, to my eye's point of view, it's going to appear as if there was light coming from this point, right? And that's where optical illusions, like one of the videos that I have in the slides about making a 3D optical illusion kind of thing with your phone shows you that. There are all kinds of optical illusions where, right, you can have a situation where it appears that something is coming from a certain place, but all your eye knows is that it can trace the rays back and see where the light seems to have come from. And so it's just, this is just as good as an image. This looks just as real, basically, as the light coming directly from the object. Okay, so that's the basic process involved here, and then just a couple more terminology things to make connections to what you'll see in the notes and in the reading. So this distance, I should use a different color. This distance here, from where the object is located to where the lens is called the object distance. Not surprisingly. And I bet you can guess what this distance is going to be called, where the image is. This is called the image distance. And those are really important things to notice, and you're going to be playing with those in lab, like how, what happens for a given kind of lens, what happens as I change this object distance, how does that affect where the image is located, or whether you can even form an image at all. Okay, and then one more before I end this video so that it's not too long. One more thing I just wanted you to be able to think about is just definition. So what's called the focal length of a lens. So focal length, by definition, is the image distance when the object is very far away. Basically, we say at infinity. Obviously, you can't put it exactly at infinity, but when what that means from the point of view of the light rays, so the light rays come in parallel. See how up here, these light rays are diverging from the point where the object is, but if the object is farther and farther away, these become more and more parallel. And so what you would see is, here's your lens, here's your light rays coming in, and for an object that is really, really far away, essentially at infinity, those light rays will come in parallel. And then you can look and see where they come to focus for light that is coming in parallel like this. Where do they come to focus? So, here d object is equal to infinity. And then this distance then is what's called the focal length. Okay? And the reason it's significant is because it allows you to have a specified, an easily controlled kind of light coming in and see how far away from the lens it focuses that light, because that basically characterizes how much this lens bends the light, right? So a really strong lens will have a small focal length because it'll bend the light a lot. A really weak lens will have a very long focal length. You think about just like a plate glass window with no focusing power will have an infinite focal length, right? Because parallel light coming in, hopefully, will just keep going out parallel. Okay, so I think that's enough to get you started and hopefully help you make sense out of the notes and the reading and what you're going to be doing in lab.